Cron has become a valuable tool for developers. Recurring tasks can be scheduled with confidence they'll be carried out, but it's an external tool, which means developers often have no control over it. There are some alternative approaches that can make such situations easier, but most are hackish and not near as reliable, having to rely on HTTP's request-response model. Building on a talk from Openwest 2013, this talk explores a few of these options and how to implement them in your own PHP projects. All right. So obviously this is revisiting a presentation I gave a couple of years ago, hopefully a little bit better than then, because we always want to improve. So I'm going to be focusing on what cron is used for in PHP development, and then various ways that we can work around not having access to it. Cron is an external tool that is used on most Unix systems for scheduling tasks. Probably already know that if you're sitting here. So we're looking at other ways to schedule tasks that will be performed repeatedly or on a schedule. Let's see. And we want to be able to pull that into PHP itself so that we're not relying on an external tool that our code doesn't have control over. So let's see. Let's get into it. First, a little bit about me. I'll skip all the boring details you don't care about anyway and jump straight into the one relevant reference I have. I am a contributor to the PHP Rescue project. It is a queuing engine. It's actually the PHP port of a Ruby project started by GitHub. The PHP version has since stalled, but I still try to handle comments in the issues section until the maintainer has the ability to go in and choose other individuals to have push access to the repo, and we can move forward. We're getting pretty close to electing one of the forks as the primary because he just doesn't have the time. But that's all beside the point. What in the world? Okay, that's supposed to say what is it used for, but I forgot to shorten that one. I apologize for that. Cron is used in PHP projects for two main categories of tasks. Background maintenance, things like checking whether a post needs to be released. You go through and you check periodically, are there any posts that have been scheduled to be released today at this time, and then you release them. Things like that. Or other background maintenance, such as backing up your database or cleaning things out that are extraneous. It also is used for deferred tasks. So I need to send out an email, but I don't want to do it right now because that'll slow things down for the user, especially if the email server takes 10 minutes to respond. So I'm going to defer that to run in the background whenever a cron task can get to it. So when we're using cron, the basic operation looks like cron fires off. It checks to see if there are any jobs to run. It runs them if there are any jobs that have been specified, hey, do this, in order until they're all done. It stores the status of each of the jobs and then moves on to the next job until it runs out. At least, hopefully, it continues to run through them all until it runs out. Pros, it's a well-used and documented approach. It's been used for years to make sure that these things fire on schedule. And it runs without user interaction, which is something that's kind of important when we look at some of the ways that we've already come up with to work around it in here in just a moment. As cons, it is external software, so it requires something outside of the control of the PHP developer. It also requires configuration external to your application. You can't just go in and modify the cron tab directly. You've got to use system tools or have access to write to those files, which normally isn't the case. It's not easy to verify or update the configuration and make sure that it's working properly because PHP doesn't have the ability to hook into that part of the system to make sure that the cron process is running. Or at least it isn't guaranteed that you have access to those capabilities on most servers. And then long-running tasks may not complete before the next cron run, if they ever complete at all. And that's a big problem because then you have the same task running on top of itself, on top of itself, on top of itself. You're backing up your database 30 times simultaneously. Suddenly your database is locked up and your website crashes. So those are all problems that we face with using cron. Now another approach, this one is used by projects like WordPress. And WordPress actually refers to it as poor man's cron, so this is not my name for it, this is theirs. It looks basically like you get an HTTP request in, you generate the response, and then you check for jobs. And if there is a job, any jobs at all, you grab the first one, run it, store the status, and you're done. You only have enough time to run one job at a time. Now that is assuming that you even have the time to run that task before PHP says, okay, I'm done. So as pros, it doesn't rely on an external cron, but as cons, the long-running tasks will negatively impact your user experience. I'm going to wait for this email to be sent, and then I'm going to give you the results of your request. And that really slows down your user experience, and you lose users that way. The tasks also can't run until a user request comes in. So if your site goes without traffic for 3 days, all the tasks that were supposed to run during those 3 days never run. And then again, as with normal cron, any long-running tasks may not complete before the next cron, the next scheduled run of that task, if they ever complete at all. And there's no way to check failure conditions reliably in that case either. So here's the approach that I'm going to try to focus on a little bit. It's called the queue and worker approach. The architecture is basically you fire up a PHP CLI process, and it's called a worker. And when the worker starts, the first thing it does is look to see if there are any jobs to perform. It runs the first one, if there are any, stores the status, and then goes right back to checking for jobs. If there isn't a job, you, in some implementations, will have it wait for a pre-configured number of seconds before it checks again, so you're not hitting your database or whatever queuing engine you're using so hard that it collapses. And then it will check again. But that way you have a process that is dedicated to running your jobs, running on the server constantly. As pros, it doesn't rely on the external cron, and it doesn't require user interaction. So those tasks will fire. However, as cons, your jobs have to be written specifically for being run by a worker. And the queuing engine you use will determine what kind of worker you're going to build and how to interact with those jobs. Most of them work very, very similarly to the others, to the point where the Laravel project has actually built a queuing engine that can abstract out all of those details. You just tell it which one to connect to, and everything else is handled exactly the same, no matter which one you're using. But of course, it then relies on queuing engine dependencies. So if you're using the Redis queue, for example, which Rescue does, Rescue uses Redis as a backing store for your tasks, you have to have Redis installed on your server. It has to be available. So there are pros and cons to all of the approaches. This isn't a perfect replacement, but it is better in a lot of ways. So the queuing engines that are supported by Laravel, and the Laravel project is doing everything they can to take their components for the framework and export them in a way that you can use them in your own projects independently of the rest of Laravel. So there's a project called Illuminate/Q, that's the composer name, that will provide this functionality. And it supports Beanstalk, IronMQ, Amazon SQS, and Redis. It does not support Rescue, but as Rescue is frozen and the Redis implementation that Laravel is using is almost the same, they're pretty much interchangeable in this case. And if you're already familiar with these technologies, Beanstalk is a queuing engine that it's open source. You run it on your server and off you go. IronMQ is a little bit different from the other queuing engines in that you when you queue a task, you actually make a request out to an external service, and then when that task is supposed to run, it will actually make a request back to your application. So it's kind of a hybrid of the queue and worker and poor man's cron approaches. So you can guarantee that you're going to get that request in on a regular basis, but it still is an external request. So if that's what you're looking for, it doesn't require you to install anything extra on your server, so it has the advantage of being able to run pretty much anywhere. Amazon SQS is their queuing solution for Amazon Web Services and their affiliated cloud technologies. And then, of course, Redis is a key value store, kind of a database, kind of not. And it's fairly popular. So there are two ways that you can set up recurring tasks. And it depends on how you're using your queuing engine. Illuminate/queue will actually allow you to schedule a task to run at a specific time. So it will fall under the delayed tasks if you want to use that approach. But you can also create a scheduler task even in there. The way that a scheduler task works is you have a special task that you build, just like any of your other tasks that you would run, and you fire it off when you fire up your application, your workers, or your front end, as part of your deploy. And the scheduler task, when it gets pulled off the queue and run, will check to see if there are any tasks that need to be run. And if you're setting your project up in such a way that you want to catch all of the missed tasks and make sure that they run as well, for example, if you had a server downtime but you still needed to send out emails at a specific time, it can go back and check, okay, when was the last time I successfully ran? Let me run everything since then that was supposed to run. So it can check for missed tasks as well if you want in your application. Some applications don't call for it, so it is optional. It'll queue, in most cases, one instance of each task found rather than queuing every single run, because then you run into the same problem that you had with cron, in that your long-running tasks may not finish before it gets started again with them stepping on each other. So generally, you'll only have one instance of each task. But again, it depends on the tasks and how you designed them. And then it'll sleep for whatever interval you have set in between when you want scheduled tasks to fire, or recurring tasks to fire, rather, excuse me. And then it'll queue itself to run again, so that it will schedule the next batch. And then it'll sleep, and then it'll schedule the next batch. And it's kind of a workaround with the queuing engines because they aren't really designed for recurring tasks. But that's why I actually prefer the delayed tasks approach. Your mileage will vary depending on your project for which one works better for what you're doing. With delayed tasks, when you start your worker, one of the things that your worker will do is check the schedule of tasks that you have scheduled and see when is this task supposed to run next? When is this task supposed to run next? And so on and so forth. And then it will queue those tasks to run at those specific times. And again, the Illuminate/queue queuing wrapper will support that approach of, hey, I want to schedule this to run at some point in the future, but not right away. And so we're relying on that in this case. And again, if you want to check for missed tasks and make sure that you queue them, this is the point where you would probably do that. And then the main difference here is that the worker then steps back and just works. The tasks then are responsible for queuing a new instance of themselves to run at the next scheduled interval. Now this allows you to sidestep the, oh, this didn't finish running before the next one started, because you don't even schedule the next one to start until the previous one finishes. And failure conditions are pretty easy to keep track of with a queue and worker approach. I have not met a queuing engine yet that doesn't track failures. I'm sure there's at least one out there, but I wouldn't recommend any of them. And so you can actually check for failed tasks as one of your recurring scheduled tasks and rerun those or report them to an admin for investigation. So, grabbing all of this and condensing it into one quick run, you take your queues and your workers, you set up your queuing engine, you schedule your tasks, and then you set up your recurring scheduler based on whether you're doing the scheduler task or the schedule this at approach, whichever approach you want to use. And suddenly you don't need cron anymore. Again, it does require you to run a worker, and it does require that you have your queuing engine installed or otherwise available. But it does keep all of the code within PHP, so you do have control over that. And it's a lot easier to tell if PHP is doing something it's supposed to be doing than it is to see if the system is. That's all I had for this. So if there are any questions, comments?
Since PHP rescue's frozen, do you have a recommendation on something else for PHP?
I would recommend Illuminate/Q. The Redis engine for it works almost exactly the same way and is a little cleaner.
Doesn't it use like basically you cron at a minute and it handles when things happen? Oh,
there's no cron involved whatsoever.
Oh, well, yeah, the Illuminate queue, but
yeah.
As far as how, like artisan jobs, that's how it does it. Okay.
Yeah. Yeah.
I've heard of Gearman. Isn't that another thing?
Gearman is another option. I don't know why Laravel isn't supporting that one. I'm sure that their developers have a reason, and if you dig through if I dig through the mailing list, I could find it. But it is an option, and it is available on a lot of servers, but it wasn't included in the Illuminate Q package. However, it's fairly easy to use and set up on your own, and the documentation is pretty good from what I have read.
Is that just a queuing manager, or is that?
That's the engine. Just lost the recorder. Yeah. That's the queuing engine that actually checks the tasks and basically manages the tasks for you.
Was Rescue queuing engine, or that?
It was a bit of both. Rescue actually gave you a worker as well. Now, granted, that worker was meant to be an example, but most people just use that version right out of the box and don't bother changing it.
Do you use? Oh, sorry.
My question is about workers. Say I were to restart the PHP engine, how would the worker be initialized? Does it automatically come online when the PHP engine, or if I were to restart Apache or something, it just starts and it goes and it waits until it feels the trigger? How does that work?
Your worker will actually be launched in a separate process, so you'll have to, as part of your deploy, set that up to. It's a little complex to explain, but very easy to implement. In much the same way that you have Apache set up to automatically start when the system does, you would have your worker set up to start when the system does as well.
Okay.
It runs in the CLI interface, so it's a script that you start from the command line.
Okay. And that script would be, I'm thinking in terms of my code base. If I were to pick up my code base and drop it on a new server and execute it, the script that initializes the worker would be something that gets stored in the PHP code base as well then?
Yes.
Okay.
Yes. Theoretically, you can write it in any language you want. One of the strengths that Rescue had when it was still active was that you could actually write your jobs in any of the languages that it had been ported to, so Ruby, PHP, I think there's one for Perl and one for Python. At the time, you could have your workers written in whatever, and then you have your web interface queuing these things, and it could be written in whatever of those languages it wanted to be, and you could run all of them simultaneously on the same server farm. But PHP is falling behind on that one, as I mentioned. But yes, it would be in your code base. It would just be one of the scripts that you fire off as part of your deploy.
Have you done any of this in a distributed system? We want to move away from Cron because we don't want to run just one web server anymore. So, I'm curious if you had thoughts. You just run a separate queue and like worker server?
Yes. With one of the Yeah, I should have put this in the presentation. Thank you for bringing it up. One of the main strengths of using the queuing engine is you have one server that manages your queue, and then you can have as many different workers on as many different servers as you want, running off of the same queue. So you'd have a Redis server, for example, and then you have 3 or 4 worker systems connecting into that Redis server to get jobs off of the queue.
So you would generally want like a single queuing server, then you could have as many workers.
Yeah. And there are ways to distribute those as well, depending on which engine you're using. The most recent version of Eliminate Queue actually supports a database driver as well. I wouldn't recommend it because, for the same reason that Redis is used over standard databases, and that is atomicity. You can't guarantee that when a job has been pulled off of the queue, someone else isn't going to try to pull it immediately after you. You end up with a lot of race conditions. And databases are slow by comparison to things like Redis or Beanstalk. But it has added a database driver just in case you want to use it. So you could do a MySQL server cluster and connect into different parts of the cluster from each of your workers if you wanted.
Do you have any recommendations on the process of moving off of Cron to a queuing system, and maybe what jobs aren't appropriate for to be put into a queue system that were appropriate for Cron? I guess this is moving off of Cron first.
Yeah. Well, okay, as far as the migration path, you will have to adapt each of the tasks that are being run to run as tasks. So they won't necessarily have access to your entire application state, for example. Excuse me. They should still have access to the databases and the configuration and so forth because they're the same code base generally. But they won't have the same application state that a Cron approach might. On the other hand, you're firing these off as CLI scripts from Cron anyway, so it's about the same. You just have to have your queuing engine in mind and refactor the code, basically. It's fairly straightforward to do. You're just saying, hey, run this function in this class in most implementations. That's obviously going to be the first step. You have to have your queuing engine set up and working, so you have your workers going. But that's really all there is to it. Once you get the tasks rewritten for the queuing system, everything else works pretty much exactly the same. As far as tasks that would be appropriate for Cron that wouldn't be appropriate for queuing, I can't think of any off the top of my head. I'm sure there are some. Anything that is working with a local file system where you want to have a task fire off on that system and not across an entire cluster would be something that Cron is better suited for because it will run on that specific system. You have to have the same task on every system you want to apply it on, obviously. But anything that has to run locally, Cron might be a little bit more intelligent for. But there are ways with queuing engines, you have multiple queues per engine. So you can have a high priority, a low priority, and you can have one based on the host name of the machine. And tasks for that host are dropped on that host's queue, and that host is the only one that has workers listening on that queue. So really, there isn't much that queuing engines couldn't do instead of Cron. Mostly it'll just be down to weighing the pros and cons of the various approaches. Did that?
Yeah, I think so. I didn't have an answer in mind.
Okay, I was just making sure that I answered your question correctly. So. What else?
If you don't mind, could you revisit again what the difference between the delayed and the scheduled tasks were?
Yeah. Rewind here just a little bit so I've got my notes. With the delayed tasks, the queuing engines themselves, and I'm using Eliminate Queue in this particular example because it's what's on my brain at the moment. They have the capability of telling the queue system, hey, put this on the queue at this time. So the task isn't actually on your queue until that time. And then when that time hits, it'll drop that task onto the queue, and off it goes.
So it's scheduling when it gets added to the queue instead of scheduling when it's going to get pulled off the queue.
Now the scheduler task is a task that you write yourself that checks the schedule manually rather than using the built-in. That's really the only difference. Is the delayed tasks you use the built-in, the scheduler task you have to implement it yourself. If that's all, here's how to contact me if you'd like.